Good evening, ladies and gentlemen. I greet you once more on our program of mathematics. Sorry. Today we are going to continue with the last part of statistics at level 4, where we would have understood level 3 stuff. So to start with this, the last part we are going to deal with when we are dealing with statistics. There's a lot of information in this particular chapter for this level because they've got to cover all that information which they are going to use when they go to for employment. So the following objective will be covered as we go on theoretically as usual. So in today's class, the 10th of March 2025, we have data handling and probability. So today I will be tackling the data handling part, statistical part, then probably trying to terminate it in the part 2. Then we touch a little bit of probability. Since there's a lot of information, I see it's prudent enough not to rush the students. So it's nice that we have to do the first thing is to have knowledge and understanding of the section in level 2 and level 3. You can follow with the videos I posted earlier on. So you should be knowing the section level 2 and level 3 pertaining to data handling, which are really required at this stage. Look at this stage, there are some points I would like us to remember. At level 2, level 3, there is no student who is going to continue when they failed the subject. So we are quite sure that the student is well informed. He has assimilated enough to sit for the final exam. So we are just finalizing, putting more icing on the cake. So there's a nota bene here, a note well. Statistical analysis can be applied to various situations. Like I said in my previous introduction when I was saying about why we are studying statistics. Here they put it as a nota well or nota bene. They say to various situations, for instance, in health, statistics is found, social, economic, cultural, political, even the environment. We use statistics to know what's happening in the environment, especially this global warming. We are constantly looking at the numbers. How is the temperature? How is it affecting? All that is statistics. It is scientific evidence that we use to see how the world is being eroded through these devastating natural disasters. Secondly, we need to discuss the use of appropriate and efficient methods to record, organize, and interpret given data by making use of, we are going to use a data sample size. What do we mean by a sample? I'm talking of in LISA we have our students. So if I want to find a particular study for students, how they are doing, for instance, how they are doing mathematics at level 2, I don't take the whole classes. My population in terms of that, it is also the level 2 in that class. So I take maybe a class, then I analyze. So through statistical inference, I would say the population, even if it's a country, we can just take one province. Then we analyze. Then we say we sampled such a population. Therefore, the whole country can be that, provided your analysis are not biased. We shall get somewhere there when we do practical in our usual discussions. So sample size is subset of a population. That's the simple as all that. A sample is a subset of a population. So you pick a particular number of objects, then you study them. That's what they call a sample size. So you need to know that sample size. Also, you have to actually understand the graphical representation and the numerical summaries that are consistent with the data and clear and appropriate to the situation and targeted audience. It's quite clear. You have to actually know the graphical representation. There are a lot of graphs you would have done at this level. You shall name them as we go down. Then I see I have mentioned them somewhere. Those graphs are necessary for us. Now they are comfortable. They are swimming in statistics, and they can immediately pick what it is all about. It is getting more interesting here because we are going to group now two bivariate data, as I was saying before. You are dealing with two situations, two conditions, and you want to see if there is a relationship. That's how it becomes very sweet at this level. It is really comfortable and interesting. If it is splendidly uh, uh, elaborated. That was the discussion of appropriate methods. Those are the methods I was talking, the graphical and the sample size and so forth. So they need to know at this level as well, graphical representations of data. What do we mean about that? They've done frequency distribution tally table level 2. They can put the tally 1, 2, 3, 4, 5, 6, 7, frequency 7, and so forth. So they were aware of that. It is a language on their own now. They are just polishing up. They don't take time on that. Sometimes they have to work during the night, like now, the night evening when it is silent. So you find that they are motivated to finish, and it is always the best time. Uh, Also buy compound charts, level 2, 3, good stuff. Stem and leaf plots, we discourage them now. We remind them. Some of them love to it that some people, when they are stranded in exam, stem and leaf, they just draw a tree, then they put these numbers on the leaves. That's the stem and leaf, which we would not have studied in the class. That's panicking for someone who is not coming for lectures. So if you don't attend one lecture, there's this spiral development which is taking information from the ground upwards. So if you cut it, it would be very hard, almost impossible for one to continue in that instance. Stem and leaf, let me go on pointing out that I've talked about this. Talked about it. This one is out as well. Frequency bind compound stem leaf histograms, we talked about them, so interesting, which come to frequency polygon, pie charts, box and whiskers, ogive caves. This is just something they would have known from level 3. This is simple stuff for them at this level. You don't have to stress yourself and try to panic it. Sometimes you just tell them, you are lecturing now, you are not teaching. Just give them and say, guys, let's do this. And for those who are good enough, they would have already finished the book before you have known it. Because right now from here, we are going to look at function and algebra, where they are going to deal as well as derivation and integration, which would have found at grade level 3. It becomes very interesting. You really see the relationship of these concepts as you grow up. I've seen a lot of youngsters doing well at this level. They never looked back. Some of them even went further, even taking even more qualifications than their lecturers, which is quite motivating. That was the third objective in terms of data handling at this level. The fourth one, which is numerical summaries of data. They've learned about Measures of central tendencies, mean, mode, and median. These are two related aspects. We need to actually marry them together. That's the central tendency, actually the box of information, it's statistical information. That's where we focus mainly. We shall see further on that when we are looking at the box, how is it distributed? We are going to touch a little bit at that. At this level, they are just listening. They are very curious. They ask a lot of questions. And they are opening up because at an university level or further there, they talk even better aspects of statistics in practice now. It's no longer theoretical or something to play with. They see it and touch it to transform and know the world they are going to. Okay? So mode, mean, and median, we have always been talking about. Measure of dispersion. At this stage, you find that the measure of dispersion is now changing term for the sake of selling books, maybe. The standard deviation is now deviating from where? From the point. Deviating, deviation is the same as dispersion. So there is one and the same thing. It's only the terminology which might confuse people in this aspect. So measures of dispersion, which is ranged in the quartiles, Q1, Q2, and Q3. Interquartile range as well as semi-interquartile range. Interquartile range is very important when they are talking about outliers or the fences. Lower fence and upper fence, there's need for one to understand the interquartile range, because the formula talks about adding and subtracting Q1 and that aspect for the lower fence and upper fence. It was just statistics live as we see. So interquartile range, semi-interquartile range. The fifth one, variance. What is variance? It's just a matter of using it's a verbose language. Variance is varying from where? One position to another. The same thing, dispersion. There are means of calculating the dispersion of bidirect data now. There are two data we're talking about. It's no longer univariate data at level 2 and 3. Yes, at level 2 and 3. Here now we are comparing, want to see the correlation coefficient, the relationship which exists between where they are selling cars, BMW and the other one, maybe Benz. They want to see how much we sell internationally. For instance, or they can be fruits, mangoes and bananas. You're selling them. You see how much is there a correlationship of selling these true fruits? Do people buy them? Or the correlation coefficient R is 0, which means there's no relationship whatsoever. You might take bananas as oranges, some of them get rotten, so you have to change your inputs. All that is we saw it in economics. It was mentioned that's economics, finance. You're dealing with money, but the statistics is also interfering there. Very useful. So use variance and regression analysis, which I'm talking about, regression line relationship between those. Interpolate and extrapolate bivariate data. This is the key point I've always been emphasizing. By the two. So that one will be two dataed information, bivariate. Then you have to interpret the meaning of the representation of the box and whisker. This is very crucial. I've put it in red to say, how do you interpret a box and whisker? You would find that there's Q1, Q2, and Q3. We only are interested in relating the Q2, which is the median and the mean. That's what the relationship we want to see between that box and whisker. So it says that if it is positively skewed, you would find that the mean is greater than the median. The median is there, the mean is up there. That's positive. So if it is equal, that's symmetrical. If mean is equal to the median, that's symmetrical. It's normal distribution, as we shall see it in few minutes to time if you come. And it is also skewed to the left when it is skewed to the or negatively when the mean is less than median, right? So this is getting more enjoyable. Okay, so all these you have to understand the representation. What does it mean? It's not just a matter of just going into the desk and they say, here's a box and whisker. You have to explain geographical or diagrammatical representation of your information. Why have you put them into a graph? To make to actually to shrink your information, a voluminous information, you shrink it into a diagram. So it needs really patient and non-biasness. You should be a man of his word as far as statistics, because if you mix the words or the numbers, your your days as a statistician will be numbered, if we were to say. Now we are looking at that was the sixth one. Now the one-to-one, they say calculate variance and standard deviation manually for small sets of data only. At this level they are studying, you are not working. But when you are working in the factory, they give you files. Sit down the whole week. That's a voluminous, momentous information for a company. Here we are studying, we are not working. So at this stage, they are just small that besides some of them are not mathematicians, they're just passing through the maths to their courses. Like a physician, he just picks maths, a chemist, and so forth. They pick maths, they are not specializing in that. But if you are really specializing, you need to put that out as necessarily wanted as possible. So what do we mean by standard deviation or variance? It's nothing else but what I've just said, that dispersion. Maybe they've thought of say standard deviation, the deviation which is dispersion of double information. Probably that's why they are using deviation instead of dispersion. But it's one and the same thing. Because variance is dispersion of data as well as standard deviation. Find first variance, then square the variance to get standard deviation, numerical value of that. So when you put it on the graph, you will see there's what we call confidence interval, which I shall be talking very shortly. So how do we calculate variance or measure of dispersion of double data or bivariate data? You say x squared would be the sum of bracket xi minus mean bracket O squared, which means you are saying x1 minus mean squared plus x2 minus mean squared, going on and on, divided by n minus 1. These formulae are always given to you. There's no need to put them to put your mind with unnecessary information. Things like formula, you need just to understand, or like sequences and series, you just have to pick it. It's a matter of picking the formula, then feed the information. That's why in level 2 we talk of substitution in formula or make subject of the formula. You need to pick up, even in shapes, space and shapes. You need to know what is a cone and its formula on a set of, by mere studying, not by memorizing. Memorizing will make Jack and Jill you. So like I said, if you want to find the standard deviation now, you square, which is you find the square root of the variance. If you are given the other, you square it, one in the reverse of the other. Now, this would be the first part of statistics, so that we can give a breather to understand some of it. But before we finish, I will take last but not least objective today's class, which is objective 7. We are talking about, I've been talking about how you have represented your information on the box and whisker, and you have interpreted what it means when mean is less than that, when mean is greater than, or mean is equal to that. It's a normal distribution. So we actually have at this level, we are going to talk of a normal distribution. Normal distribution, because there's what we call confidence intervals, which actually is going to deal with mean minus first standard deviation, less than x, less than mean plus first standard deviation. That is the first. Let me put it in words as it is, but it's more or less what I'm trying to illustrate. That for normal distribution, the following intervals called confidence interval are defined. You can check with any other textbook you use over the side of yours. It's fine, just one and the same thing. Okay, it doesn't change. Even the language, just the letters, the language can change, but it's one and the same content. So they say 68.27% confident interval is found. Listen here. Mean minus first one standard deviation is less or equals to x, less or equals to mean plus first standard deviation, which means the 68% is found within the one space from the mean, because it's in the middlemost where the mode they are there. So if we move this inside 1, that's they form 68. As we go x plus minus 2 that side, x plus 2 that side, we have what we call 95.45% confidence interval, because you are increasing the deviation. It's like you are marking a student's paper. We say our standard deviation is 3, which means it's going to be minus 3 and plus 3, but that's a lot of marks, which is 6. So you have to be very careful on your confidence interval if you have to mark correctly and moderate accordingly, because at this stage we are looking at not failing students, because they've come very far. So at this stage you should be open-minded and be realistic to the answering of the student, because they have their own methodology of understanding this concept. You might say the way you think is wrong, yet the student is right. So there's a really need for whoever is going to mark those students' papers to thoroughly study and find different methods, not one or two, because there are different ways of answering this question. So there's the 95.45% confidence interval, 2 interval to the left, 2 interval to the right of the mean, any value which is found there. Then they have what we call 99.70, almost the whole cover, 99.73% confidence intervals will be followed by the mean minus 3 standard deviation. It goes further like that. It is going to the tail of the more normal distribution. Then we talking of the other side would be mean plus 3 standard deviation to the right. So doing, there will be the probably you would see it if I put it like this. These are the two here. The one, this is the negatively skewed normal distribution and positively skewed. We shall discuss and continue on part 2 when I'm going to be discussing further how we can plot information and the scatter graph. How do we put two information on a scatter graph? Then we find best fit of line. It is going to be very interesting as we shall terminate or we culminate this particular topic of the level 4 at the teacher's service. I thank you once more for joining me today. I didn't come for the 3 days. I had gone for a sports, which is the right of the people. We need to do sports and do a lot of them so that we can psychologically be ready, physical fit, mentally as well. Thank you so much. Good evening and thank you. Next time we meet, enjoy yourself. Bye.